Saturn I 1B Quarterly Film Report number 20 covers progress during the period April, May, and June 1964.
Off. Right, vent level. Right, zero. 2 vents. 0, 25, 25, 50, 50, 75, 75, 100, 100. IPC, manual calibration.
A highlight of this report period was the launch of the 6th Saturn flight vehicle, SA-6. This vehicle was the first to carry an Apollo spacecraft boilerplate and launch escape system. It was also the first flight to use an ST-124 for active guidance. The SA-6 launch, scheduled for May 26th, was scrubbed during countdown due to an environmental control system compressor malfunction in the ground facilities equipment. 2 days later, the final countdown began. At T-minus 85 minutes, a hold was caused by additional time required for ST-124 stabilizer azimuth alignment. At T-minus 70 minutes, a second hold was called due to a ground facilities valve freezing in the open position. At T-minus 41 seconds, a third hold was called because ST-124 alignment could not be verified due to LOX boil-off vapor breaking the theodolite beam. The LOX vent line has been rerouted to a lower level, eliminating the possibility of this condition during future countdowns. The count was recycled to T-minus 15 minutes. At 12:07 p.m. on May 28th, the vehicle lifted off. Vehicle performance was as expected for the first 117 seconds of flight. At that time, booster engine number 8 shut down due to a mechanical failure in the propellant turbopump gearbox. SA-7 and subsequent vehicles will incorporate an improved propellant turbopump gearbox. The engine-out circuit shut down the faulty engine, and the remaining 7 engines continued to function, burning 2 7/10 seconds longer than programmed, partially compensating for the loss of engine 8. The deviation from the programmed trajectory was compensated for by the ST-124 guidance system, which became active shortly after second stage ignition. Prior to this time, an ST-90S stabilized platform system guided the vehicle. Starting with the next flight vehicle, only the ST-124 will be used for guidance. Final booster cutoff occurred 149 seconds after liftoff. Ullage and retro rocket action was as expected. The flight of SA-6 was recorded by the standard ground cameras, 2 television cameras, plus 8 onboard movie cameras, which you see returning to Earth. These cameras were successful in recording flight data such as aerodynamic effect on blowout panels, opening of the blowout panels, LOX sloshing in the center LOX tank, S4 engine chill down, stage separation. S4 stage ignition and performance were successful, placing the SA-6 satellite consisting of the emptied S4 stage, instrument unit, and Apollo boilerplate into an Earth orbit lasting 3 3/10 days. As a result of good performance with SA-5 and SA-6, S4 stage helium heater backup hardware and excess fuel will be eliminated from future vehicles, saving 1,500 pounds. On May 28th, the booster and instrument unit for the 7th flight vehicle, SA-7, departed the Marshall Center aboard the barge Promise and arrived at Cape Kennedy 10 days later. On June 9th, the booster S-17 was erected at Launch Complex 37B. Also, by the 9th of June, both the Apollo service module and the command module had arrived at the Cape by air from the West Coast. Following a successful acceptance firing and final checkout earlier in the quarter, the second stage, S-47, was flown from Sacto to the Cape, arriving on June 12th. Receiving, inspection, and preliminary checks on the stage were completed, and the stage was erected at the launch complex on June 19th. 4 days later, on June 23rd, the instrument unit SIU-7 was also moved to the launch complex and erected. Following mating of the stages and pre-flight checkout, SA-7 is scheduled to be launched next quarter. At Marshall's Quality Laboratory, the booster for the ninth flight vehicle SA-9 is undergoing post-static checkout in the pressure test cell. Following testing, the stage will undergo electrical checkout prior to preparation for shipment to the Cape. Early this quarter at Michoud, following pre-static checkout, the S-18 was prepared by Chrysler for shipment to Marshall. On April 17th, the booster stage was loaded on the barge Promise. The stage was shipped from Michoud the same day and arrived at Marshall on April 26th. At MSFC, the booster was erected in the static test stand and static firing preparations were begun. A short duration firing was scheduled for May 21st, but was rescheduled when a leak developed around the manhole cover in the center LOX tank. Later, the stage successfully completed two separate static firings, one for 45 seconds on May 26th, the other for 143 seconds on June 11th. On June 24th, S-18 was shipped back to Michoud, arriving on June 28th. Modification and repair operations began the next day. Also, at Marshall's Michoud operations, checkout of the Chrysler-built S-110 began on May 4th and will be completed early next quarter. Following completion of checkout, the booster will be prepared for shipment to MSFC next report period. At Douglas's Santa Monica facility, S-49 checkout was completed April 28th. On May 8th, the stage was shipped to SACTO and installed in the static test stand. S-49 acceptance firing is scheduled during the next quarter. Meanwhile, on April 25th, the S-48 was moved from DAC's assembly area to the vertical checkout area. Checkout, hampered because of parts shortages, is now underway. No major problems have been encountered to date. Also at Santa Monica, stage assembly of Douglas's S-410 stage continued during the quarter and is on schedule. Vibration testing by Wiley Laboratories of the first unpressurized designed instrument unit was completed during this report period. Minor modifications made in this unit as a result of testing will be incorporated on flight units SIU 9, 8, and 10. Completion of SIU 9 component installation and beginning of checkout at MSFC is scheduled for early next quarter. On June 15th, SIU 8 structure was removed from storage and transferred to the Manufacturing Engineering Laboratory for component installation. Checkout of SIU 8 is scheduled to start late next quarter. SIU 10 is in storage awaiting start of component assembly next quarter. On May 20th at MSFC's test laboratory, the complete dynamic test vehicle in the SA-9, 8, and 10 configuration had been installed into the test tower. The upper stage dynamic test for the SA-9, 8, and 10 configuration, which tested only the S4 stage, instrument unit, Apollo boilerplate, and micrometeoroid capsule, was completed last quarter. The complete vehicle test continued throughout this quarter and is scheduled for completion in July. At Michoud, Chrysler fabrication and assembly of the S-1B1 thrust structure assembly and second stage adapter were completed in May. On June 19th, clustering began on S-1B1. The first 6 H-1 flight engines, uprated to 200,000 pounds thrust, were delivered to Michoud during this quarter. S-1B1 will be the first stage using the uprated H-1 engines. In mid-June, fabrication began on the second stage adapter spider beam for S-1B2. The barrel assembly for this stage was completed during this report period, and the outriggers were attached. Meanwhile, the S-1B mock-up fin was completed. The fin, which can be mounted on the tail section mock-up, will generally be used as a development fixture for routing of plumbing and wiring. During this quarter at Michoud, construction work for S-1B test facilities included a concrete block building housing the air compressor for the computer facility and brick and mortar construction on the card tape storage building. At the close of last quarter, the S-4B structural and dynamic test stages were in Douglas's vertical assembly towers at Huntington Beach, California. Early this quarter, the structural test stage was moved from its assembly position and transferred to the structural test building where strain gauges and other instrumentation devices were installed in preparation for the hydrostatic portion of the structural test program. On June 23rd, the finished stage was moved into the hydrostatic tower. Hydrostatic pressure testing of the LOX and LH2 tank is scheduled to begin in mid-July. Assembly of the propellant tanks for the S4B dynamic stage was completed in March. The stage was then moved to the hydrostatic test tower. During hydrostatic test operations on the S4B dynamic stage, a valve controller in the facility's test equipment malfunctioned, causing a negative pressure in the liquid hydrogen tank, which resulted in depressions in the LH2 dome. The depressions were later popped out by filling the tank with water. During inspection, cracks were found in two weld seams. These cracks were repaired and the stage has been successfully retested. Stage insulation installation was begun late this quarter and is expected to be completed early next quarter. During this report period, the S4B all-system stage was processed through assembly towers 1 and 2, where welding of the LOX tank assembly and the LH2 forward dome to the LH2 cylinder was accomplished. The stage was then installed in the hydrostatic tower. At DAC's Sacramento test facility, final inspection of facility contractor effort at the Gamma Complex Test Control Center and Instrumentation Center has been completed. Completion of the entire Gamma Complex, including test cells, has been temporarily delayed due primarily to late delivery of approximately 65 valves of various sizes and types. Inspection and testing of these valves is now underway. Also, at SACTO's Beta Complex, installation of instrumentation at Beta Test Stand Number 1 is complete. The J2 engine for use in the battleship program was received in April, checked out, and subsequently attached to the stage. Preparation for cold flow testing of the battleship stage began the first week in June. Construction continued at Beta Test Stand Number 3, scheduled to be completed next quarter. The stand will be used in testing the S4B all-systems stage. The liquid hydrogen test tank will be transferred next quarter from Marshall's Manufacturing Engineering Laboratory to the test laboratory for additional technological testing. Insulation was installed in the tank during this report period. The container will be used in the study of super insulation for liquid hydrogen and LOX tanks. Also, at Marshall's Manufacturing Engineering Laboratory, installation of some components is underway on the Saturn IIB instrument unit vibration test unit. Work is scheduled to be completed in early August. Then the unit will be prepared for shipment to Wiley Laboratories on August 31st for vibration testing. Fabrication is complete on the Saturn IIB and Saturn V instrument unit for the dynamic test vehicle. The unit will be in storage until August 10th, when it will be transferred to the test site. Results of vehicle dynamic testing will furnish necessary data influencing control computer filter design. A significant highlight of this report period was the gimbaling of Rocketdyne's J2 liquid rocket engine. During the tests, the engine was gimbaled at 30 degrees per second. Gimbaling was programmed through 3 cycles in both phases to a maximum of 10 degrees. These hot firings met all PFRT requirements. In April, the S4B battleship hot-fire J2 engine was turned over to NASA. Delivery was made at Rocketdyne's main facility, Canoga Park, California.